Yeah, hello everyone. Hello everyone. Welcome to IGC. So you all are happy. Today you all are happy, right? So guys, just respond. Am I audible? Please respond, guys. Am I audible? Yeah. So those who are happy, please just inform in chat. So 2024 paper was quite approachable, right? And it is quite approachable for most of people, right? Whoever have prepared well for last 1 year or specifically in last 2 3 months, right? So guys, it's a easy paper. It's an easy paper. So you guys should not be so relaxed, okay? Because today you all are happy and same happiness should carry till result come. So in this session we are going to analyze gate 2024 aerospace engineering paper, and myself Dinesh. I am an chief I am an organizer at IGC, okay? And this is all about gate 2024 aerospace engineering exam. Yeah. So first thing, we have done multiple polls on our YouTube channel, on our Telegram channel, and with our internal students, and we found paper standard is easy to moderate. So the paper was easy, specifically for those who have prepared very well. Okay, specifically IGC students, and in IGC also those who are writing mock exams. Really, with all efforts they found it is very easy paper, and for others also paper is moderate. So those who have focused more on pyqs, because as per feedback, some questions from pyqs got repeated with some data change and all. Okay, so the paper is easy to moderate. So one thing is very simple: when paper is easy to moderate, for sure cutoff will be high, and gate score against obtained marks will be less. Okay, so that will be a worry, okay, for you all, because again the competition will be with other branches like mechanical and all during admission. Okay, now good student in this paper could attend 55 plus questions. Okay, either it is from IGC or any other place. Average attempt for people those who have prepared relatively okay is 40 plus minus question. Okay, uh, and except engineering mathematics. Actually, in this paper, they made engineering mathematics bakra. They didn't ask much. They just asked 4 questions. Otherwise, paper was very balanced across all the modules of syllabus: structures, flight mechanics, aerodynamics, propulsion. Okay, and they have given little more age for propulsion compared to other aerodynamics module or structures module or flight mechanics module. So it was kind of 2016, which was ISC paper, and in terms of the easy, you can say 2018 and 2019 papers were easy. So you can see, you can expect, you know uh, what is that? Failed to do eccentricity, very cheap. I'm not sure what he's writing. Okay, so this is about the kind of paper is and toughness part, and the cutoff. It's a rough cutoff. Once we get the response sheet and marks from all the students, we can predict in a better way, but close to 30. Okay, and the gate score against marks will be lesser among all recent papers. So you guys can expect. Okay, so you guys can expect uh, the gate score may be little lesser against obtained marks. So this is about the broadly about paper part. Now if you see the subject wise question asked, aptitude as usual 10 questions are there, and engineering mathematics here they made the difference. Okay, so only 4 question. Aerodynamics around 7 question. Gas dynamics as usual like last 2 years, around 4 to 5 question. Here propulsion again 13 14 questions are there. This time they did well in flight mechanics. They gave 5 questions from stability. If you take 2023 paper, I think there was no stability question or only one, and 7 questions from performance, so it was balanced well. And if you take strength of material, around 7 question, 3 from mechanical vibration as usual. Aircraft structures 1 to 2 questions, so they won. And in space dynamics, this time they asked 3 questions as per feedback. Usually they ask 1 or 2. So this is how total 65 questions were asked in exam. And in terms of questions, there were more NATs and MSQs, and there were less MCQs. So the advantage is that there will be less negative marking for those who have attempted high number of questions. Okay, so this is about subject part, the type of questions they asked, and the NATs were straightforward. Most of the NATs were straightforward, easy to solve. So those who have solved NATs with accuracy, they will get very good marks in this paper. So that is about subject weightage. So guys, any concern or any doubt? I think whatever I am discussing, is it clear? Yeah. Now paper analysis, since it's a easy paper, so advantage is what all of you are very happy, and you guys should be happy after this paper. And most of you could attempt good number of question. Okay. And again, now accuracy will matter most. What are the disadvantages of this paper? We have discussed internally 1 week before itself. The gate scores are usually low in EG paper against obtained marks. So you may get very good marks. You may get like 57 marks or some 55 marks. So with this 55 marks, this time your gate score may be 600 to 650. In earlier paper with 55 marks in 2023 kind of paper, your gate score is always greater than 700 or 700 to 750. So clear. So your marks this time may be more, but your gate score may be not that high as like previous tough papers. Okay. Now, what are the good marks to get very good rank? Like 55 plus marks is good with is attempt with good accuracy to get good 2 digit rank. Okay, under 100 kind of rank. And if you want to get single digit rank, then your attempt should have been around 60 plus minus, and with the accuracy of around 80%. So those who attempt around 60 plus minus, their attempted marks will be around 90, and with 80% of accuracy, they will be getting around 75 marks. So you guys can expect in this paper the top rankers will be 75 plus minus. Okay, it's top 10 ranker. So the top marks may be around 75, or maybe may go up to 80 also. Okay, so but once we get marks of different candidates from response sheet, once we prepare key, we will be definitely sharing that rank prediction session. We will be doing rank prediction session also. Okay, so this is about top rankers part or single digit rankers. Now, how was paper for IGCians? The paper was very good for most of the IGCians who have prepared sincerely over the year or over last 3 4 months specifically, and last 2 months as well. And most of the questions came from IGC work straight away, either from mock exams, some questions from PYQs also, but we provide solution for all PYQs. Yeah, of course, we'll be start discussing question. Okay. And quickly, okay, not to worry. Yeah, it's a good attempt, 53. And paper was quite easy compared to IGC mock exams, so all IGCians found easy. Okay. And of course IGCians will be best ranker among all. Okay. Now another information, we are starting our gate 2025 batch from Feb 18th, and those who are going to prepare sincerely for gate 2025, they can contact us for any support if they are looking, or if they are looking for any proper and good coaching with IGC. So these are our contact details, and you guys can reach to us on these contacts. Okay, either or through phone or mail, or you can visit website and put a query. And these are our social media handles. Now we will be starting with math and aptitude part. Thank you all. So any question, guys, regarding this paper part? Quickly, guys, can put a question if you guys have any. Otherwise, we'll be starting solving questions. Thank you all. Yeah, Mithilesh, please share
Yeah,
your
yes. Could you please share the YouTube link so I can see the
yeah, yeah,
questions from
okay.
student?
Yeah, sure, sure. I'll be sharing in your WhatsApp.
Hello, everyone. Welcome to IIT's Gate classes. Now we'll start solving the questions from engineering mathematics and aptitude. So let's try solving all the questions one by one. First question is from mathematics, and it's from the numerical methods, where they are asking us to find the integration of a given function by using trapezoidal rule. So basically, the trapezoidal rule says the integration of f of x here is like, you can say it as y is equal to h by 2 in bracket y naught plus yn plus 2 times y1 plus y2 plus so on till yn minus 1. So this is the formula for trapezoidal rule. And yeah, let's they're asking us to use a single interval. So interval is from 1 to 2. So the strip size, or interval size in this case, is h, which is equal to again 1. And so we can say that when the value of x is equal to 1, what is the value of function? That we can call it as y naught. And when the value of the function is 2, we can call it as a y1, which is yn in this case. So the value of y naught, the function is equal to 1 upon 1 plus x square. So it will be 1 upon 1 plus 1 square. So it is 1 upon 2. And yn will be 1 upon 1 plus 2 square, which is 1 upon 5. So the value of y1 or yn will be 1 upon 5. So using this equation number 1, we can find it. Y is equal to 1 by 2 because h is 1. Y naught is 1 by 2. And yn is 1 upon 5. We don't have any other terms, so you can ignore it, since we are dealing with only one single interval. So if you further solve it, it will become 7 by 10 into 1 by 2, which is equal to 7 by 20. And if you solve it, it is 0.35. Okay, so it's quite easy. Do you have any question in this? Do you have any doubt? Okay. Then let me proceed towards the next question. Okay, this question is there. If P plus Q is proportional to P minus Q, then the value of P by Q is, and they have given the options depending on P and Q, constant, depending on P, or not known. So let's try to solve it. Starting with the given data, P plus Q is given as proportional to P minus Q. So we can say that P plus Q is equal to K times P minus Q. And if you simplify it further, P plus Q will be equal to Kp minus Kq. Let's take the P and Q on either side. So it will be P minus Kp is equal to minus Kq minus Q. So further, if you take P common, it will become 1 minus K. And here, if you take minus Q common, it will become 1 plus K. And now P by Q can be written as minus of 1 plus K divided by 1 minus K. So we can clearly see K is the proportionality constant. And if we add or subtract 1 and then make its division, it will end up with again a constant number. So we can say it is a constant. So option B is correct in this case. We got one question here from Rohit about the previous question. That is, can we have 0.39 as an acceptable answer? So I'm not completely sure, Rohit, what is the range they have given you within the question, whether it's up to 2 decimal places or 1 decimal place. So depending on it, it will vary. So, and yeah, if they give a range like 0.3 to 0.4, maybe in that case, your answer is also acceptable. And if they give very precise range, 0.34 to 0.36, then in that case, they may ignore it. So yeah, it's depending on what range they have decided and how many decimal places they are mentioning in the question. Okay, coming toward the next question. This is about the log functions. Let's try to solve it. So they have given us that log of p square plus q square is equal to log of p plus log of q plus 2 log of 3. And they're asking us to find the value of p raised to the power 4 plus q raised to the power 4 divided by p square q square. In this case, we have to understand that how can we get the term p raised to the power 4 and q raised to the power 4. So maybe you can multiply with a 2 on both the sides. What you can get is like 2 times log of p square plus q square is equal to 2 log of p plus 2 log of q is equal to 4 log of 3. Sorry, plus 4 log of 3. Then this 2 goes here. It will become p plus q bracket square. So it will be log of p raised to the power 4 plus q raised to the power 4, because p square plus q square whole square is p raised to the power 4 plus q raised to the power 4 plus 2p square q square, and that is equal to 2. So we can say log of p square plus log of q square plus log of 3 raised to the power 4. This term will become log of p square q square plus log of 3 raised to the power 4. We can even take this term to the left hand side. It becomes minus, and the other term becomes only one term remains on the right hand side. Now let's use it. So on left hand side we have log of p square, sorry, log of, let me go to that slide. log of p raised to the power 4 plus q raised to the power 4 plus 2p square q square. So log of a minus b is equal to log of a by b. So p raised to the power 4 plus q raised to the power 4 plus 2p square q square divided by p square q square is equal to log of 3 raised to the power 4. Here also log. So we can cancel the log on both the sides. So this will become p raised to the power 4 plus q raised to the power 4 divided by p square q square. If you break it at this point, okay, and then one more term here you'll have, because that is 2p square q square divided by p square q square. Okay, and that is equal to 3 raised to the power 4. Okay, so you can cancel out these two terms, you will end up with a 2. This is what the required term. So p raised to the power 4 plus q raised to the power 4 divided by p square q square plus 2 is equal to 81. So the answer is 81 minus 2. And yeah, that is what 79 is the correct answer in this case. Okay. Yeah, most of you have answered it correctly. Let me go to the next slide. Yeah, we have this question from the differential equations. Let's see what it says. They have given us the value of y, and they are asking us to solve a differential equation d2y by dx square plus 2 times p dy by dx plus p square plus q square into y is equal to. Let's solve it. So the value of y is given. From this value of y, we can calculate dy by dx. I'll directly write the dy by dx term here. It is p e to the power px, or let me write it e to the power px into bracket p sine of qx plus q cos of qx. And if you simplify it inside, it will become p e to the power px sorry, yeah, e to the power px sine of qx. Second term, q e to the power px cos of qx. So this is how the dy by dx term looks like. Let's find the d2y by dx square term. d2y by dx square term, I'll directly write. So basically, this is more or less same as the question, given question, except we have p in multiplication. So you can directly write by making use of this first, the same derivative. So d2y by dx square will be p square to the power px cos of qx plus pq e to the power px cos of qx. Similarly, now you have to take a derivative of e to the power px cos of qx and then multiply with a q. It will come as pq e to the power px cos of qx minus q square e to the power px sine of qx. Okay, this term I have directly written here, but yeah, if you solve it by using formula e to the power ax sine of bx, you will get it. And so basically we have this one term here, and from this term we are subtracting 2p dy by dx. So I'll directly write one term here, minus 2p dy by dx term. How it will look like? It will look like as minus 2p square e to the power px sine of qx sine of qx plus, this will become minus 2pq e to the power px cos of qx. And the last term we have is p square plus q square into y, p square plus q square into y, and that is equal to, so y is our e to the power px sine of qx, so it will be p square e to the power px sine of qx plus q square e to the power px sine of qx. So this is what all the terms will look like. Then try to cancel them out if it is possible. Yeah, we can clearly see that we have one, this is like 1 pq e to the power px sine of qx, then one more term is there, that is pq to the power px cos of qx, so it will be 2 pq e to the power px cos of qx, and that will get cancelled out with this negative term. So these three terms will get cancelled out with each other, 1, 2 and 3. Then we have a negative term q square e to the power px cos of qx, and then we have positive term, so these two terms will cancel out with each other. And then we have p square e to the power px cos of qx, one more p square e to the power px cos of qx, and this is a negative term, and these two terms will cancel out with each other, hence the answer is 0. All the terms are getting cancelled, so you'll end up with a 0 as answer. Okay, I hope it is clear. Yes, most of you answered it correctly. Good. Let me go to the next slide. Yeah, this one is from the linear algebra. They are asking us to find the ratio of largest eigenvalue to the k. So largest eigenvalue is maybe lambda max and divided by k. So in this case, first of all, we have to calculate the k, find out the eigenvalues, and decide the maximum or largest eigenvalue and take the ratio with the k. In this case, they have given us the value that determinant of a given matrix is 3. So let's first use that data to find it. Determinant of given matrix is 5, 4, a minus 1, determinant equal to 3. So 5 into minus 1 is minus 5, minus 4k is equal to 3. So minus 4k is equal to, this minus 5 goes on the right hand side, it becomes 8, right? And this implies k will be equal to 8 by minus 4, so it will be minus 2. So the value of k, first of all, in this case is minus 2. Now we'll make use of this k and put it into the this equation and get the value. Okay, we have some comments here. We have some plus 4k. Is there any wrong with the given question? Because I have one comment here from Abhishek. It is plus 4k. So what is given there? Can you write it? Is there anything wrong in the question? You think, okay, it was minus 4. Okay, in the question it was minus 4. Let's correct it then. Try to correct it. Okay, this is minus 4. So yes, then it will become plus 4k, and then it will become plus 2. Okay. Okay, we have one question here. We have one comment here from Shashwat. I got minus 1 by 2. Okay, so yeah, maybe let's solve it, assuming it as a plus 4, because some students got it as k as a minus Okay, most of them are saying minus. Let's keep it them minus. Okay, let's keep it as +2 then. Okay, maybe. Okay, this is the question we have got from some students. We'll correct it now and proceed. Fine. Tell this. Is it clear to everyone? Anyone have any doubt? Okay. Then we'll proceed towards the calculation of the eigenvalues. So it will be phi u minus lambda, and then k minus, let's put the value of k as 2 now, then minus 4, and then minus 1 minus lambda. Okay, so this is how we'll do it. Take a determinant of it and make it equal to 0. Okay. Some students are saying that answer was negative. Let's see how it comes, and then I'll will decide. Okay, because yeah, there is a confusion in this question. Some students are saying it is -4. Some students are saying they got answer negative. Let's see it. So 5 minus lambda minus 1 minus lambda. Okay, and then it my plus 8 is equal to 0. Okay, because we have taken here 2. Yeah, I think -4 should be right. Okay, that is what it looks from as of now. So if you multiply it inside, it will become minus 5u minus 5 lambda plus lambda square plus 8 is equal to 0. So it will become lambda square minus 4 lambda plus 3 equal to 0. So if you get the lambda here, it will be lambda, either you'll get 3 or 1. So this is lambda is equal to 3 comma 1. So max out of this is 3. So lambda by 3. So 3 by 2 will be 1.5. So 1.5 is the correct answer, because in this case the maximum eigenvalue is 3. So you have to consider that one and divide with the value of k, which we got 2, and hence 3 by 2 is 1.5 is the correct answer. Okay, if assuming that here it is -1, if this is +1, then things will change. Sorry, if this is -4, then it is correct. If it is +4, then the k value will become negative, and I think you'll end up with a -1.5. So that is how it will look like. But as of now, yeah, most of you are saying here it is -4, so we corrected it, and with that, the answer comes as 1.5. Okay, most of you got the correct answer. Largest eigenvalue is 3 and k is 2. So yeah, 3 by 2 is 1.5. Okay, then anyone have any other doubt? Is it clear to all of you? Can we proceed to the next question? Okay. So this one is, yeah, you can say from the aptitude. Okay, what they are asking is volume of the shaded portion is, okay, so we have a sphere here, and we are cutting the sphere at a certain height, and then let's try to solve the volume of the shaded portion. Okay, there is a direct formula for it. Okay, the formula for calculating the shaded portion is given by h is equal to.
I think, sir, there is some comment for last question. Can you go back?
Okay, yes, so
And what is the comment says?
a sir is v9 minus 4 the negative term of the eigenvalue. Okay, I think the comment is okay, so basically there is confusion here whether it's a -4 or +4. In our question, we have considered it as a +4. If you consider it as a +4, the answer comes as a -1.5. And if it is -4, in that case, it will come as +1.5.
No
So
problem, sir. I think
yeah,
that's we have given both options, so we can move on next.
yes, yes, yeah.
Thank you, sir.
So yeah, coming here, the volume here can be calculated. Let's imagine this as the h. If this is the value of h and capital R is the radius, then the volume of the shaded portion is given by pi by 3 hs square three r minus h. This is the question. This is the formula which we can directly use in this case. They have not given us h, but indirectly they have given the this height because angle is given to you. You know, cos of 60 degree is equal to 1 by 2, and that is equal to base divided by hypotenuse. So base is you can say r minus h, right? So r minus h, and divided by hypotenuse is r, and yeah, so basically this implies r minus h is equal to r by 2, and of course h also has to be r by 2 then, right? So h is equal to r by 2. So this is this cut we are making at half of the radius. Putting this into the formula, what we'll get is volume is equal to pi by 3 into r by 2 whole square into 3r minus r by 2. Yeah, if you solve it further, pi by 3 r square by 4, and this is 3r into 2 is 6r minus r, that is 5r by 2. Yeah, so finally you can write it as pi by 3, or let's say pi r cube, and the constant term here is 5 divided by 24. And now what they have said is the volume of the shaded portion is k pi r cube. So this k pi r cube is equal to 5 divided by 24 into pi r cube. So you can cancel out these two terms, and the value of k, you can say that 5 by 24 comes as 0.2083. Okay, any doubt in this question? Okay, basically we are supposed to find the k in this case. You know, the volume of the sphere is always in terms of uh, like the total volume is 4 by 3 pi r cube. Half will be 2 by 3 pi r cube. So basically pi r cube term will be always there, and that will get cancelled. So the constant term is what we are supposed to find. So it should not be in terms of pi, Atharva. So something maybe missing here from your side. Uh, anyone got this answer? Yeah, maybe it was a little bit difficult because in this case we were supposed to know this formula. Otherwise, deriving this formula will take long time. And if you know it front, then it becomes very easy because you can put it in this case. Let's say h is equal to r by 2. You will end up with the 2 by 3 pi r cube formula. If you put h is equal to minus r, you'll end up with 4 by 3 pi r cube. So either you have to create in case you don't remember this. So the correct answer in this case is 0.2083. Okay, no problem. Next question. Yeah, this one is very easy from the probability. Two fair dice are rolled. What is the probability to get an odd number in both the dice? You can post your answers. So probability of getting an odd number. Odd number is, is when you throw a dice, you'll either get 1, 2, 3, 4, 5, or 6. Then probability of getting an odd number is 1 by 2. And yeah, so we want that if you are rolling a 2 dice and we want to get the probability of getting odd number on both the dice. So it will be odd number on the first die, and whenever we say and, we are adding more requirements and our probability will decrease. So we'll use the multiplication sign there, and 1 by 2 into 1 by 2. So this is like a probability of getting odd number on the first die, and probability of let me add it here, and probability of getting odd number on the second die. This is how you will represent it, and it is 1 by 4, which is 0.25. Yes, most of you answered it correctly. If you don't want to solve it like this, you can also just write down whatever the outcomes you are getting whenever you throw 2 dice. So you will end up with a 1, 1, 1, 3, 1, 5. These are the possible outcomes with odd numbers 3, 1, 3, 3, and 3, 5, and then 5, 1, 5, 2. Sorry, 5, 3, and 5, 5. So these are only, you can say, 9 possibilities we have to get the odd numbers on both the dice. So basically, total number of favorable outcomes in this case are 9, and number of possible outcomes are 36 when you roll 2 dice. And hence, again, in this way also, if you calculate, you will end up with the same answer. So whichever is easy, yeah, you might have used it. Let me go to the next question. Yes, so this one is from the aptitude again. We have a surface area of the cube, and that is equal to the area of rectangular sheet. So what is surface area of the cube? Surface area of the cube is 6a square, right? Because cube has the 6 sides and area of each side is a square. So 6a square is the surface area of the cube, and that is equal to area of rectangular sheet, that is 54 into 9. Sorry, 54 into 4, and that is equal to 216. This implies a square is equal to 216 by 6, which is 36, and this implies a is equal to 6. Okay, now what is the question? The long edges are joined to form a cylinder. The ratio of volume of the cylinder to the volume of the cube. So basically these two long edges, this is long edge, this is another long edge. We have to join these two long edges to make a cylinder. So this is how the cylinder will look like. Okay, so for this cylinder, what is the perimeter? Perimeter is 4 centimeter, and that is equal to now 2 pi r. Pi r is the perimeter. So you can say now this 2 and this 4 will get cancelled. So you can say pi r is equal to 2. And pi square r square can be written as 4. and basically pi r square can be written as 4 by pi. Why I'm writing it, I'll show you. What they are asking is the ratio of volume of the cylinder to the volume of the cube. What is the volume of the cylinder? Volume of the cylinder is, let me use this space here. Volume of cylinder is equal to pi r square h and divided by volume of cube, which is a cube. So pi r square, we need pi r square term. That's why I have calculated it. So that is 4 by pi, and height is 54. 4 by pi, height is 54, and a cube is the you can say the volume of the cube, so which is 36 into 6, or let's say 6 cube also you can write, right? So 6 ones are 6 9, and 9 ones are 9 fours are, then 4 ones are 4 ones are. So it's 1 by pi is the correct answer. So in this case, option A is correct. Yes, most of you have answered it correctly. 1 by pi is the correct answer. Okay, let me go to the next slide. Is it clear to all of you? Any doubt in this question? Okay, I'll proceed to the next question. A rectangle with dimensions 20 cross 8 is folded 3 times perpendicular to the longest side. What is the perimeter after 3 folds? You know what is perimeter? Perimeter is equal to 2 times length plus width. Okay, so in this case length is 20 and width is 8. So we have to fold it 3 times perpendicular to the longest side. So this is our longest side, right? L is our longest side. If I fold it once, it will become like this, right? So it will become 10 by 8. Okay, first folding. If you do the second folding, it will become, so I have to fold it like this here. So I'll just draw the dotted line here. It will become 5, 8, and if you do it 3 times, third folding, it will become 2.5 and 8. So if you calculate 2 into 2.5 plus 8, yeah, so solve it. It will become 10.5 multiply by 2. That will become 21 as the answer. Okay. Any doubts in this case? Okay, we have some comments here. Some student got 18. Okay. Okay, so here. Okay, understood. So yeah, maybe yes, some of you have considered here that at this stage you can have the fold is like this. Okay, perpendicular to the longest side. Okay, then how it will become? It will become, yes, so it will become like this, 5 and 4. So 5 plus 4, it is 9, 18. Yeah, I hope some of you got it like this. Yeah. So assuming that the wording in the question is folded 3 times perpendicular to the longest side. Okay. Yeah, means if it depends on complete how exactly it is put it into the wording in question. If they say that whichever is the perpendicular side, then yeah, 18 is the correct answer. And if it is about this length, then the 21 is the correct answer. But yeah, looks like the wording is about the longest side, so 18 is the correct answer in this case. Yeah, because majority of you mentioned it as about the longest side we have to fold, then yeah, in that case the correct answer is 18. Yeah, okay, most of you got it. Good. Let's go to the next question. Okay, let's go to the next question. Okay, this was one question posted by someone in our group, that f of x is equal to x square if x is okay. This function is valid when the value of x is um, less than 0, and when x is greater than 0, greater than equal to 0, the value is x. Okay, so this is what the given data we have, and they are asking about the continuity and differentiability of the function. Okay, the clear question is not available, but this is what we have. Some 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 students may have doubt that it can be greater than or equal to the opposite signs. That is what we saw in our group. But in any case, we'll study how the problem will look like. So if x is less than 0, then it is taking a parabolic curve, and yeah, ultimately it will meet 0. And then for all the values of the x greater than equal to 0, the value of the function is behaving like a straight line, that is y is equal to x. So this is how the curve will look like. This is x, this is f of x. Now let's solve it. So basically we can, just by looking into the curve, we can say it is a continuous. So the option with the continuous has to be selected. Okay, so imagine like there are multiple options, continuous and differentiable and continuous and not differentiable. Then we have to check the differentiability part as well. So first of all, it's continuous. Okay, it is very clear that both the curves are meeting at a point. There is no discontinuity here. Now just by looking into the graph you can tell. What about this differentiability? Any guesses? We can clearly see the slope of the curve here is 1. In this case, the slope of the curve is becoming as 0 as we approach. Okay, so or you can perform the check. Okay, we can know that we can clearly say that right hand derivative in this case is 1. Okay, what about the left hand derivative? Left hand derivative you can calculate. Limit x tends to 0 from left hand side, f of x minus f of a divided by x minus a. Okay, so f of x is x square in this case. F of a is basically 0 divided by x minus 0. A in this case is 0. Here f of 0 you can directly write. And basically, yeah, limit x tends to 0. Limit x tends to 0 from negative side. And you can clearly say x square by x is x. And if you put the value of x, you'll end up with a 0. Because you can clearly see the curve is horizontal, becoming a little bit horizontal here, right? if you approach very, very close to the 0, the curve becomes horizontal, means its slope is 0, and that is what is we are getting. So it's correct. So the left hand derivative is not equal to the right hand derivative. Hence, this is not a differentiable function. So continuous, yes, but it's not a differentiable function. So the correct answer is you have to see that it is a continuous but not differentiable. Okay. Okay, we have some questions about the previous question. I'll come back to that. Some of you got 18, some of you got 21. Okay, because we clearly don't know how the wording of the question is at this point. So whatever you have told us on that, we made these questions and explaining you. Is there any doubt on this particular question? Is it clear, this differentiability and continuity? Most of you got it correct, that it is a continuous and not differentiable. I'll go back to the previous slide. Yes, so as I said previously, I calculated that.
Yes, one thing, Mithiles, actually this aptitude was common for CS also. I think same question. So these guys can further dig their
Okay,
head later,
okay.
because see this CS Institute might have got whole paper by sending
Mhm.
some marketing people,
Okay, okay.
inside exams. Yeah, yeah. Thank you.
Yeah, yeah. Okay, just one comment I'll add is like it's completely depend on the wording here. If they say about the length, in this case the answer is 21, and if they say about the whichever is the longest side, then it is 18 is the correct answer. Coming towards the last question, this question is not clear. Uh, how is the figure looking like? Okay, whatever information we have, we will try to draw it. So this is how we have the figure from some students. Yeah, and the question is number of squares to uh, make this figure symmetric about the AB. So yeah, you know that we have to add one square here, one square here, one square here. Okay, and yeah, of course, one square you have to add here. Okay, not that one. Then okay, we'll add one square here and one square. No. Yep. So here I think the tricky part, like whether this is correctly given to us. So yeah, okay, one square here we'll add, and yeah, I think one square is here. So basically 6 is the no okay, let me, so one will come here and one will come here. Yes, so just a minute. The blue ones are the ones which are given. Okay, and the um, red ones are one which we have added. So on the right hand side, it is pretty clear that you need to have 3 squares. On the left hand side, yeah, so basically here if you add one more, then basically this 1, 2 and 3. So basically 6 is the correct answer, which looks to be correct. Any doubt? Okay, so this figure is a little unclear, but yeah, um, looking into the options, 6 is what we feel is the correct answer to make it symmetric. Yeah, most of you have got 6. Then yeah, I think it should be correct. Okay, sir, that's all we have from the mathematics and aptitude point of view. Thank you.
Yeah, so for your, you know, patient support. So guys, next we will start aerodynamics. So you guys are ready for aerodynamics and gas dynamics? Yeah. So Mr. Sanjay, I'll hand over presentation to you.
Yes, sir. Can you make me presenter? Yeah.
Yeah, you are presenter now. Yeah, thank you, Mithilesh sir. So we have put a lot of effort actually for math, but they didn't ask much. But nevertheless, math is very important for all other subject, and it
Yep.
is also important for their future work. Yeah,
Yes,
thank you,
thank
sir.
you.
Yeah. Can you confirm the screen is visible?
Yeah, yes, Sanjay, it's visible.
Okay. All right. Good evening, guys. So so we got a feedback that the paper was of easy to moderate level. That's what you guys have responded. So now let's look into questions from aerodynamics and gas dynamics. So guys, see, this is memory-based questions. So it's based on what you guys have remembered after the exam. So we still do not know what are the exact wordings and the exact sentences in the question. So unless we get the question paper, out, we cannot really confirm our answers. So this is just based on whatever we have heard from you. All right. So let's start one by one for aerodynamics. Okay. Right. So here you see this question. I think I'm not sure what was this, whether it was an MCQ or NAT. Okay, it was an NAT. Fine. So find CL for a NACA 0012 airfoil for angle of attack of 5 degrees. Okay. So this is a very straightforward question, right? And I just expect all of you guys would have done it, right? So at angle of attack of 5 degrees, okay. So alpha is given to you as 5 degrees. So I think this question also mentioned that thin airfoil theory is applicable over here, right? Because without mentioning that statement, it is really not possible to proceed. So assuming that thin airfoil theory is applicable, okay, we can use the results from thin airfoil theory that the lift curve slope, that is CL alpha, is equal to 2 pi. Okay, so the lift curve slope is 2 pi. So how you can find CL? CL is very straightforward. It is just 2 pi into alpha. Okay, because it is a symmetric airfoil, right? NACA 0012 is a symmetric airfoil. You see the first two digits, it says that we do not have any camber, right? So it is a symmetric airfoil. We do not have a zero lift angle of attack. So CL would be simply be equal to 2 pi alpha. Okay. So just have to calculate this, right? So 2 into pi into alpha. Now remember, guys, alpha that you'll be substituting it over here would be in radians, not in degrees, right? So you have to be careful about that. So 5 into pi by 180. Okay. So this is in the angle in radians. Okay, just have to calculate this. Yeah, I think someone has already commented. The answer is 0.55. Yeah, I think that's what most of you have got. Yeah, so it is 0.55, right? So CL is 0.55. So the lift coefficient is 0.55. Is this what you have got, everyone? All right. So I think this was a very straightforward question. Let's now move on to the next one. So if you guys have any doubts, any clarifications, please put down in the comment box. Okay, right. So here you see this question is from gas dynamics. Uh, an airplane flies on day at an altitude with speed at an altitude. So it's at a given altitude with speed v1 at temperature t1. Okay. So there you can see on day 2 the speed has now been increased. It has been multiplied with a factor of 1 point root of 1.2, and the temperature is 1.2 times the previous temperature, right? So you have two cases, right? So in case 1, let's say you have two cases. In case 1, how will you calculate Mach number, guys? Mach number m1 will be v1 by speed of sound, which is root gamma r t1, right? This is how you get the Mach number. For the case 2, it is v2 by root gamma r t2. We know v2 is nothing but root of 1.2 v1, and this is gamma r. Temperature is 1.2 times t1, right? So you can see this root of 1.2 gets cancelled out. So essentially what you obtain is m2 is exactly equal to m1. Okay, so option C should be the correct answer. Yeah, Rohit, you got some different answer. I think this was, if these are the wordings in the question, then it should be m1 is equal to m2. Maybe you have done some mistake. So others also, have you got the same answer as C? All right. Okay. So that was very simple. Let's now move on. Okay. So here you see as the question, uniform flow and source flow are superimposed at the origin. So source flow is kept at the origin. I think that's what the question meant. Select the wrong option. So I'm not sure if this is an MCQ or an MSQ. So if you guys could comment what was it. Okay, but let's see how to solve this. So you have a uniform flow. Okay, uniform flow of say u infinity, and you have a source flow. Okay, this is the source flow. Say the strength of the source is given by lambda. Okay, uh, is given by lambda, and it is given that the source is kept at the origin. Okay, so it is kept at the origin. So this is your x-axis, your y-axis, right? So guys, from the potential flow theory, we have learned the elementary flows and superposition of elementary flows, right? So from the potential flow theory, we know that when you superimpose a uniform flow with a source flow, what will you obtain, guys? What will you obtain? Can you all say? If you superimpose a uniform flow with a source flow, what is the shape of the resultant potential flow that you obtain? It is a, it would be, it would be a Rankine half body, right? You will obtain a Rankine half body. So so say here you have a source like this, and you add uniform flow, you will see that the streamlines would just, like this. So here it will go to infinity because the source flow, all the flow towards the right is from the source, and all the flow towards the left is from the uniform flow, right? So what you obtain is a Rankine half body. And guys, this is very well known from the potential flow theory calculations that the stagnation point for a Rankine half body is located at a distance of lambda by 2 pi v infinity, okay, v or u infinity, upstream of the source. Okay, it is upstream of the source. Okay, so guys, this is very important that the stagnation point is located upstream of the source. So here in this case, if the source is located at the origin, and hence the stagnation point will be at the negative x-axis. Okay, it will be at the negative x-axis. So, and what would be the distance of the stagnation point from the source? It is given by lambda by 2 pi v infinity. Okay, so now let's look at the option. First option says stagnation point on x-axis. That is correct, right? You know that the uniform flow is just aligned parallel to the source flow. There is no inclination to the uniform flow. So the stagnation point cannot lift off, right? It would be on the x-axis. So the first A option is correct. Correct means it is a true statement. Option B says stagnation point on left of the origin, which is also correct. We just saw that stagnation point will be on the left of the origin. Increasing U will shift the stagnation point to origin. So you see guys, the stagnation point is given by lambda by 2 pi u infinity. If you increase the free stream speed, that is u infinity, what do you observe? The stagnation point distance will reduce. If the stagnation point distance reduces, it will move closer to the origin, right? So option C is also correct. Okay, and what does option D say? Increasing Q. So here Q is the source strength, so it is nothing but lambda. For the source, will shift the stagnation point to the origin. So again, you go back, see this expression for stagnation point. You see it is directly proportional to lambda, right? So if you increase the strength of the source, what will happen? The distance of the stagnation point from the source will increase, which will uh, make the stagnation point far away from the source. So it will move the stagnation point farther away from the origin. It will not shift to the origin, right? So clearly option D is a wrong statement, which is a correct option for this question. Okay, because they have asked to select the wrong option. Is this clear to everyone? This is what you guys have got in the exam. Yeah, so from the comments, I could see that most of you have gotten this correct. Yeah, it was a straightforward question. If you just remembered the distance of stagnation point from the source, then it was very easy. All right. So is it clear? Can we move on to the next one? Okay, let's move to the next question. Yes. Okay. So next question you see is from aerodynamics. It is in fact from the concept of finite wings. So what does the question say? Again, the entire question with the proper wordings is not there. We just got the data roughly. This is what it is. So the weight of the aircraft, or rather mass of the aircraft, is given as 1000 kg. Density is given as 1 kg per meter cube. Area is given as 31 meter square. Now, this should be the planform area, is what I feel from the question. Okay. So this should be the planform area. Planform area of the wing. Okay. So this is nothing but S, right? So let's write down the data that we have. We have that the weight is 1000 kg. So this is mass, in fact. So you have to multiply by 9.81 and get the weight in newtons. Okay. And density, free stream density is given as 1 kg per meter cube. This is the free stream density at the altitude at which aircraft is flying. Yeah, so Manjesh, you say it is steady level flight. Okay, I think that should be there because otherwise, you cannot find CL, right? Yeah. So yeah, E is not given in the question, but it is mentioned that it is an elliptical lift distribution, right? So for an elliptical lift distribution, what should be E, guys? What should be the E for elliptical lift distribution? It should be 1, right? E is equal to 1. The Ostwald's efficiency factor would be 1, right? This is what we know from the lifting line theory, right? So no, you don't have to neglect E. E is just 1. Okay. So rho is given to you S is given to you as 31.4 meters square. Span length is given, the wingspan, that is 20 meters. E, okay, is not required here because it's already mentioned that elliptical lift distribution. The free stream velocity, that is 50 meters per second. What is the induced drag in the wing for wing with elliptical lift distribution? Okay, so we have to apply the elliptical lift distribution results, right? Now, okay, so they are saying G is given. Okay, so G is 10. So let's take 10 here. See guys, again, I do not know the exact wordings, so I'm going by what you guys are telling me. So let's take G as 10. So this will become 10,000 Newton. Okay, that is the weight of the aircraft. All right, so they have given that it is a steady level flight. Okay, what do you mean by a steady level flight? Steady level flight means lift has to be equal to weight. Okay, lift is equal to weight. So, and obviously thrust is equal to drag, but here we do not have anything to do with that. Okay, so lift is equal to weight. So from here, guys, you can first calculate what is CL. Okay, we can calculate what is CL. So how will you calculate CL, guys? CL is, since lift is equal to weight, replace L by W by half rho V square S. Okay, so you calculate CL from here. You have the values, just substitute and tell me what will you get here. Yeah, so what will be the CL? It is around 0.25, right? CL that you get is around 0.25. Okay, so now once we have calculated CL, guys, we know the induced drag coefficient, that is CDI. Okay, okay, Manjesh, you're getting 0.54. I do not know. If this is the data that is given in the question, then it would be 0.25. Okay, so anyway, we'll confirm all these answers once the official paper is out. Okay, right. So here I would just see the approach. Okay, that's what we are discussing here. We are not sure about
Yes.
the values, so that might
Yes.
change. Yeah, so just see the approach. So CDI is the induced drag coefficient is KCL square, right? You all know this. It is directly proportional to the square of lift coefficient. So what is K here, guys? K is 1 by pi aspect ratio times E into CL square. We know for elliptical, E is equal to 1. So this is not there. Aspect ratio, right? How will you calculate aspect ratio, guys? You know, for wing, aspect ratio is B square by S. Okay. So just calculate. B square is 20 square by 31.4. So what is the aspect ratio that you will get? 12.73. Okay, that is aspect ratio that you get. So substitute all this here in CDI and you obtain the value of CDI. Okay, yeah, so what is CDI, guys? It is coming around 0.0016, right? This is the CDI. Now you can calculate the induced drag, right? This is what we have got as the induced drag coefficient. Now you can calculate the induced drag as CDI into half rho V squared S. Okay, so all the values are again there. We just have to substitute. Yeah, so if you substitute, what would you get is, I think, around 63.27 Newton, right? So is this what you guys have got? So I saw someone has commented that 63. Yeah, so I think this should be this. So someone has asked, can we do like this, finding alpha is equal to I, then multiplying with lift to get induced drag. But yeah, you can do like that way also. Yeah, you are correct. So you know that drag. Yeah, so this is another approach. You know that induced drag is equal to L sine alpha I, right? From the Prandtl's lifting line theory, this is what we know. For small angle of attacks, you can assume this is L into alpha I. We know alpha I is given by CL by pi into aspect ratio for an elliptical lift distribution. So yeah, once you found CL, you find alpha I and you multiply it with L, right? So in this case, again, you can take L as the weight of the aircraft for steady level flight. Okay. So yeah, you can do it by this approach also and you will get the same answer, right? Yeah, so yeah, someone has said 12.74. So I hope the approach is clear to you guys. The answers might vary with the data that is given in the actual question. All right, so let's now proceed. Yeah, so this question, again, it is not very clear what it was. So they've asked, how does this drag polar for a general aviation aircraft looks like? Okay, so I think this was a MCQ. Okay, and there were four options. They had given the curves, right? They had given the drag polar curves. Okay, so we do not know how those curves in the options look like, but we can still try to draw what is it, how does the drag polar look like. Okay, so the drag polar, you know, is given by the drag polar equation, which is CD is equal to CD naught plus K CL square. Okay, now guys, remember, in fact, I had made this point in one of the earlier PYQ sessions also, that this parabolic drag polar is valid only for a symmetric airfoil. Okay, however, if you take a cambered airfoil or in general for any airfoil, this is not the case. Okay, so what we get is CD minimum plus K into CL minus CL naught square. Okay, so we get a drag polar something like this, which is not exactly parabolic, but it is the vertex of the parabola is offset. Okay, so if you draw the drag polar curve now, okay, so I think this is this is CL, and this is CD. Okay, see, the drag polar could be drawn in either way. You can have CD on the y-axis, CL on the x-axis, and vice versa. But let's take CL on the y-axis and CD on the x-axis, and then draw. So you will see that this is something like this. Okay, so it will be like this. Okay, so here you will have the CD minimum. So the minimum CD is at CL is equal to 0. Okay, so this would be the drag polar curve. Yeah, so did you guys find this type of a similar curve in the options? Yeah, was it there? Can you confirm? One in question, x-axis. Okay, so you can even invert the axis and draw. This curve would look like vertical. Okay, the parabolic nature will not change. Okay, if you change the axis. Yeah. Okay, great. So I think this was there in the options. Then this should be the correct answer. Okay. All right. So let's now move on. Move on. Yeah. Okay. This was a very interesting question. For finite angled and cusped airfoil. Okay. Given below in inviscid flow. So definitely there should be there an option that it would be an inviscid and a irrotational flow. Okay. Inviscid and a irrotational flow. You have two airfoils, which is CP2 airfoils. So one of them has a finite angle trailing edge, another has a cusped trailing edge. Okay, and say this is one, and this is two. This has a finite angle trailing edge. Don't forget about the figure that is drawn here. So I'll draw it for you again. So this is how it is, right? This is a finite angle trailing edge airfoil. So you see that there's a angle. Another airfoil was a cusped airfoil. Okay, it's like this, right? So these are the two types of airfoil, 1 and 2, finite angle and cusped. Now guys, with the assumptions of inviscid irrotational theory, okay, with the assumptions of inviscid and irrotational flow, and of course incompressible flow, we know that for a unique value of circulation over an airfoil, it has to satisfy the Kutta condition, right? So Kutta condition has to be satisfied. Okay. Now, so let's guys recall what is the Kutta condition. So Kutta condition says that flow should leave the trailing edge smoothly, okay, for any airfoil. Now it is a consequence of Kutta condition that for a finite angle trailing edged airfoil, okay, for a finite angle trailing edge, it's from the Kutta condition that the trailing edge is a stagnation point. Trailing edge is a stagnation point. So if the trailing edge is a stagnation point, guys, if the trailing edge is a stagnation point, can you tell me what should be the CP at the trailing edge? What should be the CP at the trailing edge? Can you guys tell me? If the trailing edge was a stagnation point, what should be the CP at the trailing edge? CP is the coefficient of pressure over here. Okay, CP is defined as P minus P infinity by Q infinity. Yeah. So the CP at the trailing edge should be equal to 1, right? Exactly equal to 1, just because trailing edge is a stagnation point. Okay. Yeah, right. Now, for the cusped trailing edge airfoil, from the Kutta condition, it follows that trailing edge is not a stagnation point. Okay, here trailing edge is not a stagnation point. Guys, now if it is not a stagnation point, then the velocities leaving the top and bottom of the airfoil are the same, right? So this is say V1 and V2, then here V1 will be equal to V2, which means at the trailing edge of a cusped trailing edge airfoil, you have some velocity. Okay, it is not a stagnation point. So you know from irrotationality assumption, our CP can be written as 1 minus V by V infinity the whole square. Okay, where V is the velocity on the point on the airfoil, right? Now, if you take CP about trailing edge, you will get 1 minus V trailing edge by V infinity the whole square. So you can clearly observe here in this case that CP at the trailing edge will be less than 1. Okay, CP at the trailing edge will be less than 1. So guys, now let's see the options. For the finite angle trailing edge, CP has to be equal to 1. For the cusp trailing edge, CP has to be less than 1. So option D here is the correct answer. Did you all follow this? Yeah, is it clear to everyone? Any doubts? Okay, waiting for the response. Okay, yeah. So someone says they have gotten option D is correct. Okay. So let's move on. Yeah. So I think yeah. So there are a few more questions which which I got to know later. So let's discuss that also. So there was a question on. So it's like you have a ellipse, okay, of length say C, right? And at the upstream, the velocity profile was given as a uniform flow. So this is U infinity here. Okay, this is U infinity. at the downstream, which is the wake of this object, the velocity profile was given as a linear variation. Okay, this was given, and it was also given that this are connected by two different streamlines. Okay, this is say streamline 1, this is streamline 2, and it is all there's an assumption that these streamlines are far away from the body. Okay, they are far away from the body, and also this upstream and downstream velocity patterns are also far away from the body, so that pressure upstream can be assumed as pressure downstream. So there is no pressure difference that is causing this flow, but it is rather the momentum change which is causing the wake. Okay, now they had given the velocity profile of the wake, which is a linear profile. So it was given as, I think, u infinity y by h d. Okay, and I think this was some 0.03 c, right? This is again 0.03 c. Yeah, I think this is what was the question. Yeah, guys, can you all confirm if this was the exact question? This is what I got to know from you guys. Yeah.
I think it was kind of repetition from PYQ. There was
Yes,
similar one.
exactly. Yes, yes. There was one similar question. Also, in our mock test, we have given a lot of similar questions like this. There was an
Yeah,
elliptical, yeah, there was an ellipse body, and we had given almost the same velocity profile. So, yeah. Okay. And the question was to find the coefficient of drag, CD, that is experienced by this body. Okay. So again, let's discuss the approach. You guys can anyway solve and find it out. So yeah, first you have to find out the drag that is acting on this body. Okay. So for that, we'll do a control volume analysis. So you just take a control volume, which is surrounded by this streamline. Okay. Assume this is the control volume, and let's apply the governing equations. Now, what are the governing equations here, guys? We have the continuity equation and the momentum equation. So if you apply the continuity equation here, so I think this was given as some HU, right? The distance upstream. Okay. So let's first apply the continuity equation. What will you get? Minus, so this is the upstream. So you get minus rho into u infinity times HU. Okay, you can assume the the span along the perpendicular direction is unit, so that is one. This plus this is the exit, so you have a positive sign. Since it is an incompressible flow, you can assume rho to be constant. Okay. Now here you have a non-uniform velocity profile, guys. Okay. You have a non-uniform velocity profile, so you have to integrate. Okay. To find the mass flow rate, you have to integrate. So it is integral of u of y dy. All right. So let's take this integral from 0 to hd. Okay. So 0 to hd means I'm just integrating the one half, the top half of the velocity profile. Okay. If that is the case, then I have to multiply it 2 because there is also the bottom half, right? Because this velocity profile is symmetrical, the mass flow rate would be equal, right? From the origin, it would be equal in top and bottom. So I can just multiply it 2 over here. Okay, this has to be equal to 0, right? So there is no, because see, the 1 and 2 are given to you as streamlines. Because they are streamlines, there cannot be any flow crossing the streamline. So you don't have any other control surfaces. Okay, only 1 and 2 are the control surfaces. Okay, so u of y is given to you guys. So you just do this, perform this integration. So minus u infinity hu plus 2 times rho. This is u infinity times y by hd into dy from 0 to hd. By the way, this was hd, right? Hd is 0.03 c. So first, let's preserve this as HD, and finally, when we get the expression, let's substitute that. Okay, I think that will work. So if you do this, you get minus rho u infinity times HU plus 2 times rho. Pull this u infinity by HD out. If you integrate this, you will get y squared by 2 from 0 to HD. Okay, this is equal to 0. So if you solve this, guys, what you'll find is that HU is equal to HD. Okay, HU is equal to HD. That's what you will find. Is it correct? Did you all follow this? Yeah, is HD here delta? What do you mean by delta? So I don't know what is delta that you're talking about. So HD was given as the top length of this wake, okay, which is height of the wake. Okay. So from the continuity equation, guys, you obtain that the distance of the uniform flow upstream, sorry, the height of the uniform flow upstream is equal to the 1/2 of the height of the wake downstream. Okay. So this information is useful when we substitute this into the momentum equation and find out the drag. Okay. So let's do that. Just a second, I'll add slides. Yeah. So this is what we got from the continuity equation. Now let's apply the momentum equation. You know, from the momentum equation, we can write as minus rho u square times HU, okay, plus rho integral. You can write it as u of y square times dy, right? Again, you have to multiply by 2 if you write it as 0 to HD. Okay. No, there was no boundary layer thickness, I guess. I don't think that was specified in the question, right? There was nothing like boundary layer thickness specified. Okay. Yeah. So anyway, when we get the question, we'll confirm it once again. So yeah, guys, so this has to be equal to the net force acting on the body. So what are the net forces acting on the body? Which is surface force plus volumetric force. We don't have any volumetric force over here. So the only force is the surface force, which is a drag that is acting on the body, right? So let's represent that drag as D. And because the drag acts in the opposite direction of free stream, you can just put a negative sign, okay, to specify the direction of the drag. All right. So here you just have to substitute u of y, okay. So minus rho u infinity square, HU is HD, plus 2 times rho integral u of y is u infinity y by hd square dy from 0 to hd is equal to minus t. Okay. So from here, guys, you can just integrate. It's very straightforward to integrate. You integrate, you will obtain the expression of drag, and you can then find CDS drag by half rho u infinity square times c, right? So c is the length of the body that was given. So CD would be drag by half u infinity c into 1. Okay, you can consider the thickness as unity. Okay, so yeah, so I think that's all that you had to do. I think the answer would be, yeah, you are right. It would be around 0.02. Yeah. So I think this is what others have got. Okay, if the dimensions which are mentioned in the question are correct, then you should be able to get this answer. If not, we'll reconfirm it once the paper is out. Okay. Yeah. So let's discuss one more question, which was from gas dynamics. So there was a wedge. Okay. So this was a wedge given to you. And the wedge was, so there were three cases of the flow. and the wedge was same in all three cases. So the wedge angle is the same, theta. This is case 2, case 3. Okay. Now, what was given in the question was the shock pattern. Okay, the oblique shock pattern on these wedges in three different cases. So in the first case, the shock was something like this. The second case, it was closer to the wedge. In the third case, it was a detached shock. Okay, so here this was M1, this is M2, and this is M3, right? So this was the question. Can you guys confirm if this was the exact question? And then the options were to find the relation between M1, M2, and M3. Yes. Okay. So if you guys remember, then I think it was this. So how do we approach this, guys? So from theta, beta, m relations for oblique shock, from theta, beta, m relations, or even from the theta beta m chart of oblique shock, if you see the curves, you will observe a trend that when you keep the wedge angle theta as constant, okay, when theta is held constant and Mach number is increased, if theta is kept constant and Mach number is increased, what happens is the strength of the shock, what happens to strength of the shock, guys, when you increase Mach number and keep theta as constant? Yeah. So the shock moves closer to the body, right? Shock moves closer to the body. So you see here in case 2, you observe that the shock is closer to the body than case 1. Okay. And in the case 3, you observe that the shock is completely detached, which means when you decrease Mach number, okay, when you decrease free stream Mach number, keeping theta constant, then you will observe that for a given threshold value of m, the shock will detach, right? So m3 should be the lowest value of Mach number out of this. So m3 should be the lowest value, followed by m1, okay, because you see the shock angle is larger in 1 than 2, and then m2 should be the highest value of Mach number. Okay, so this is a direct statement from the theta beta m relations, that when you keep theta as fixed and you change m, you increase m, the shock will move closer to the body, and converse of that, when you decrease m, shock will move away from the body, and beyond the given value of m, the shock will detach, right? So is this what you all have got? Okay. Yeah, so there's one more question. Let's discuss that quickly. So I think there was a expansion fan given. So it was a expansion corner. Okay. And sorry, expansion fan was given over here. Okay. So say this is expansion fan, right? So what was given here is M1, which is equal to 2, and here M2 was equal to 3, right? Because when the supersonic flow is uh, expanded through an expansion corner, the Mach number increases. So in this case, it is M2 to M3, okay? And this is an expansion fan. What was asked is the angle of this expansion fan, theta, okay? This angle of the expansion fan, let's not call it as theta because theta we represent for the wedge angle. Let's call this as some delta. Okay, so you have to find the angle of this expansion fan, right? So guys, before finding this delta, as this is a Prandtl-Meyers expansion fan, this is the forward Mach line, right? This is a forward Mach line, and this is the rearward Mach line. right? Is a rear worm Mach line. Now you know what is a Mach line, right? You know, a Mach line is the weakest oblique shock that you can get, and Mach line has an inclination which is known as Mach angle, mu, that is nothing but sine inverse of 1 by m. Okay, so now before finding this delta, let's first find out what was the angle of the expansion corner. So this is theta, which is angle of the expansion corner. So how will you find theta, guys? You can find theta from the usual procedure of Prandtl-Meyer expansion fan, how you calculate. So it is nu of m2 minus nu of m1, right? Nu of m2 and nu of m1 are the Prandtl-Meyer function values at these Mach numbers. I think this was specified in the question. This should have been, because without this you cannot calculate theta. So from here you can calculate theta. Okay. Now once you get theta, you can also calculate the angle of this rearward Mach line. Okay, so which is sine inverse 1 by 3. Okay, this angle is sine inverse 1 by 3. Okay, so once you get this angle and you get the theta, you can now calculate this angle, the angle between the rearward Mach line and the x-axis. Okay, similarly, you can calculate the Mach angle of the forward Mach line, which is sine inverse 1 by 2, right? So I think this would be sine inverse 1 by 2. Sine inverse 1 by 2, which is 30 degrees, right? So this delta now becomes sine inverse 1 by 2, okay, plus theta minus sine inverse 1 by 3, right? So if you just calculate this based on the values which was given in the question, okay, you will get the angle of the Prandtl-Meyer expansion fan. So this was again a very basic question from expansion waves, Prandtl-Meyer expansion wave theory. So I think you all would have done this, right? Yeah, so that's all from aerodynamics and gas dynamics. I guess there were a few more questions, but let's discuss them later when we get the paper. Yeah, so do you guys have any doubts? Is it clear?
So
Okay.
I think
So yeah,
Sanjay, you have done a
yeah,
lot. Let's keep
that's good.
something for once response it comes out for that
Yeah,
as
yeah,
well.
yeah.
So,
Yes,
Mr.
yes.
Akshay, now you can take over. Thank you, Sanjay. You can tell more once response it comes. Yeah.
Yeah,
So,
yeah.
Mr. Akshay, you are now presenter. You can share your screen and we can start propulsion part. So, guys,
Can
we'll be doing flight mechanics, aircraft structures also. So, stay tuned. And once response it comes, then we'll be doing all solution as well again. So, thank you all. Keep watching, guys. Yeah. Yes, Akshay, please share.
yes. Can you hear me?
Yes, perfect.
Okay. So can you see my screen now?
Yes, Sanjay. Please carry on.
Yeah. Yes. Yes.
Yes,
Yeah. So I.
sir. Yeah.
Okay, guys. So this is based on your memory. We are going to take up a few questions that is being asked from propulsion part in 2024. So from the questions, whatever you shared, like I can see they were very straightforward questions. Let us straight away jump into the problem. So in this question, they are given like isentropic efficiency across the whole compressor, which is 0.93, and they are given the temperature at the inlet, that is T01 is given as 300 Kelvin, and a change in temperature across the stages is given as 20 Kelvin. How much stages required for pressure ratio of 10? Say let us presume that like they are given the statement in proper ways. So let us I have a compressor with an inlet condition inlet stagnation temperature of 300 Kelvin, and overall pressure ratio of the compressor is given as 10, let us say, and overall efficiency of the compressor is given as 0.93. Then say like I have a multiple stages with an each stage is distributed as a similar work done. So let us call delta T naught across the stage as 20 Kelvin, right? So if this is the case, then it is straightforward. The number of stages would be like a delta T naught, like overall work done divided by the work done in individual stage. So assuming Cp to be constant and same mass flow rate, right? So now I know what is delta T naught stage from the question. So all I have to calculate first, what is the overall stagnation temperature change. So that one we can easily calculate using the efficiency of the compressor, that we can write in this fashion. If you use the TS diagram properly, you should be able to end up in this form. So delta T naught. So I can write it for delta T naught, that is equal to T naught 1 over compressor efficiency times the pressure ratio of the compressor power gamma minus 1 by gamma minus 1. So now it is straightforward. You substitute back over here. So you should be able to get N is equal to. So you get overall temperature change for this particular problem is something around 300 Kelvin nearly, right? So like this part also you get something around 0.93, and this is already 0.93, that cancels. So you end up with 300. So divided by 20, that is closely 15. 15.0112 you get. So we have to look out for the official key, which, so like I don't know whether they are asking for round off to a nearest integer, or I don't know exactly how it is being asked, either 15 or it is nearly a 16. So one of these. Okay, so let us move on to the, so like, do you guys have any doubt in this question?
Some of them telling 17 is the answer.
Like, is this data given in this particular slide is correct?
Okay. Yeah, it should be, or it may not be. For as per our data is 16, right? That is only we need to check.
Yes. Like
Yeah,
I'm
perfect.
quite surprised with the efficiency value they are given. That is something around 0.93. That is bit higher case.
Okay.
Let me. If that is the case, like I can cross check 1 second. 0.93.
Guys, those who are watching this session, they can verify these. Are these data correct or any change? Abhishek? Are telling some issue with efficiency. So guys, we have not taken anything wrong. So whatever we are having, it's memory based. Okay. 0.83.
Yeah. So like 300 over 20. So yeah, it is something around 15. I am getting based on the. If it is
Yes.
0.8, I can agree. Yeah. So if it is 0.8 something, then definitely you are going to get a number higher than this. It's close to 70. That is
Okay.
true.
Yeah.
So
Thank you.
yeah, so the approach is what matters here. So
Yes.
don't stick to the final answer as of now unless we get the official paper. Okay. So now the next question is similar question. I was really surprised because like both the questions are exactly similar. I am not seeing anything difference here. So here also like you have a compressor, say, with some inlet temperature T01, and you have a number of stages that is unknown. We have to calculate, that is again delta T0 over delta T0 across each stage. So now they are given the pressure ratio is 10, and you have an efficiency of the compressor is 0.85. So if that is the case, then I have an individual stage where the work done is distributed as 28 Kelvin. So again, it's the same thing. If you apply the efficiency form for the overall compressor, that is T01 times T0. So from here, you can calculate what is delta T0. So I can directly substitute N is equal to T01 divided by efficiency of the compressor times divided by delta T0 of individual stage. So just like I don't have the data here for what is T01, assuming it is given between 280 Kelvin to 300 Kelvin, that's the usual range. So I would think like the answer is coming nearly at 12 stages. So is it? So then there might be some mistake, because here you are given a different value for stage, given a different value for efficiency, and I think, yeah. So if both are the same, then the approach is same. So there is no problem. Okay. Yes. Okay. Okay. Fine. Fine. So even if it is 273 Kelvin, you will be ending up around 11. Okay. So
Okay, we can move quickly to next question. No issue. Thank you.
yeah, we will just move on to the next question. So this question is a very straightforward question. Given the Cp and the value of gamma, find the value of R, the gas constant. So we know Cp minus Cv is equal to R, and we have Cp by Cv is equal to gamma. So if I just divide it by Cp, I will get 1 minus Cv over Cp, which is equal to R over Cp. So it becomes 1 minus 1 over gamma is equal to R over Cp. Or if I write it for R, it becomes 1 second. Yeah. So this is gamma minus 1 by gamma. So it becomes R is equal to gamma minus 1 by Cp times R. Right. So I don't know what is the value of gamma and Cp is given to you. So based on that, like, you can calculate what is the R value of R. So if Cp is given to be 1005 joules per kg per Kelvin and gamma is 1.4, you should be able to end up R is something close to 287 joules per kg per Kelvin. So it depends on what values of Cp and gamma is given to you. So this is how you get the value of R. So clear? Or does anybody remember the value of Cp and gamma from this question? Gamma is given as 1.33, then Cp, sorry, there is Cp doesn't come to numerator, denominator, it comes to numerator. Yeah, 1147, right? So that is, so R you should be able to get something around 285. 284.6 joules per.
Yeah, I think they asked for air only, so the answer was standard without solving. It was MCQ, I think.
No, no. 1.33 and 1147 is for the gases, that is not exactly air.
Okay.
So whatever it is given, like whatever it is given, it is fine. So R should be equal to Cp times gamma minus 1 over gamma. So you put the numbers, you should be able to get it. Straightforward question. Okay. So now let us move on to the next one. So mass flow rate of a rocket at a specific impulse of 200, thrust of 60,000 Newton, and gravity is 10 meter per second square. It's even straightforward. So because we know, so thrust can be written as mass flow rate of the propellant times the effective exhaust velocity, and we know effective exhaust velocity can be written as specific impulse times g naught. So from here I can substitute back it as mass flow rate of propellant is thrust divided by effective exhaust velocity, that is is times g naught. So say like I have thrust is 60,000 divided by is is 200 times g naught is 10. So 10 get cancels to, so it will be 30 kgs per second, right? I hope everybody got this number. Straightforward question. Clear? Okay. So if you guys have no doubt here, so I can move to the next one. Okay. An aircraft engine moving at 250 meter per second produces 60,000 of uninstalled thrust. If its thermal efficiency is 35% and fuel mass flow rate is 3 kgs per second, what is its propulsion efficiency? So I hope you provided all the necessary data here. Say like I have an aircraft with an engine mounted, so which is moving at a speed of 250 meters per second and which is producing a thrust of 60,000 Newton, and you are adding a fuel at the rate of 3 kgs per second. So which has a thermal efficiency that is given as 35%. So they are asking you to calculate the propulsion efficiency. So propulsion efficiency, we define it as thrust power to propulsive power. Also, we have a thermal efficiency that we define it to be propulsive power to heat input. Right? For aircrafts, it is propulsive power to heat input, but for general cycle, it will be net work done to heat input. So heat input, I can write in terms of mass flow. It's like usually efficiency of the combustion times mass flow rate of the fuel times the calorific value of the fuel. So in this case, let us assume the burner efficiency is 100%, and I can just replace propulsive power to be thermal efficiency times this quantity. So that becomes my propulsive power is equal to thrust power, that is given as thrust times the forward speed divided by the propulsive power, that is thermal efficiency times mass flow rate of the fuel times QCV. So now guys, please let me know whether this calorific value of the fuel is given in the question or not, because like without that I cannot give you an answer. Is it given? Because like I don't even have a value for exit velocity to proceed in the other way. I don't even have the value of mass flow rate of the air to proceed with a different approach. So I need at least one more information to complete this question. So based on the given data, so I am just given the approach. So it is given, right? 43.44 megajoules per kg. That is what given. Is it? So then in that case, it becomes, so in this case, that becomes a propulsive efficiency something around 0.325 or nearly equal to 32.5%. I'm really not sure. So it is just because of whatever numbers you are telling me. So I'm giving you the numbers here. Okay. Okay, fine. So this is how you can actually get this answer. So let us see once the official paper is out. Let us see how this question was exactly being asked. Okay. Okay then. Let us move to the next question. That's the last question from this session from propulsion part. So here it is again a straightforward problem. They are given the Cp value that is same for both air and gas. So say like in a control volume fashion, I have a combustor. So where I am adding a fuel with a calorific value, something like that with some rate. And I have a mass flow rate of air that is coming into the system. So that is having stagnation temperature at the entry is something around 700 Kelvin, and at the exit I have a stagnation temperature of 1300 Kelvin with a mass flow rate of gas that is going out. So if I do the continuity balance, so I would get mass flow rate of gas is nothing but mass flow rate of air plus mass flow rate of fuel. And if I do the energy balance, so I should be able to come to the form that is a fuel to air ratio as Cp times T03 minus T02 divided by burner efficiency is already given, it is 100%. So we can easily keep that as minus Cp times T03. Again, in this problem, from the given data, you guys are not provided what calorific value is given in the question. So can anybody confirm me which value of calorific value of fluid is given to you? If calorific value is given something near to 39 megajoules per kg, then this would be the answer. For this one, if it is given something like 32, and for this one, if it is given something around 56, and for the last one, if it is given something around 22. Is it T2 is 600? So based on the given data I provided, can anybody confirm me what is the value of calorific value? It is given 44, is it? So 44 looks some close number. Say like if you are given, if it is 600 Kelvin instead of 700 Kelvin, so then you would get you get exactly the option A. If it is 600 Kelvin, then option A. That's what you are going to get. Okay. Yeah. So that concludes problems from propulsion. I think gas dynamics part, Mr. Sanjay has already answered you. So yeah. So you
Yeah,
guys have
so
any?
yeah, I think thank you, Akshay. Let's we will answer their further concern once we solve,
Yeah. So once we
in
get the official
solution.
paper, then it
Yeah,
will be easier for us
yeah,
also.
yeah,
Okay.
yeah, sure. Thank you, Akshay, for your support. Yeah, let's Praveen, please start. Now you are presenter.
Okay, sir. So good evening, guys. Hope you are able to hear my voice and see my screen. Okay, so today we'll be focusing on the questions which were asked in the flight and space mechanics, which includes performance and stability, of course. So word is that we the in performance, they asked around 7 questions. And in stability, they asked around 5 questions. And in space mechanics part, they asked around 3 questions. But since we are still unaware of the question details, so we had around 5 to 6 questions at the max, and we will be discussing that for now. And once we get other questions, once the official paper is out, then we'll be focusing on the remaining parts. Okay, so please bear with me if any mistakes are there, but the approach remains the same. Okay, right. So let's get started with today's session. So this is the first question. They asked the ratio between the equivalent airspeed and the true airspeed at an altitude of 5 kilometer, and densities have been given. Okay, so this is a very simple problem. Reason is because the Mach number is 0.2. So we know that if you want to consider compressibility, then you have to consider the compressible form of the Bernoulli's equation. But since your given Mach number is less than 0.3, let's straight away invoke the formula, which is basically the ratio of the equivalent airspeed to the true airspeed is nothing but under root of rho by rho naught. And at it's mentioned that densities have been given. So upon calculating the rho by rho naught, so you can just write that down in here. So because I'm not aware of the question details, so if you calculate that, you will get this value, and if you substitute that in here, so you will get a value close to 0.775. So that says that our true airspeed is obviously greater than the equivalent airspeed. Okay, so this is how you should proceed problems in this part. Okay, right. So having said that, let's go on to the next question. How does density vary along the isothermal line? Again, this question is not yet clear. So let's write on the formula, and with the formula you can just clearly mention it. So in an isothermal line, so temperature is constant basically. If I plot a temperature versus the height, so temperature is constant. At the foot, it is 216.66 Kelvin. Okay, so you can just write at isothermal line. The temperature is constant. So which means what? My ratio, if I invoke the ratios from the flight performance part, so it is basically the exponent of minus g by r times t at 11 at an altitude 11 kilometer times h minus h at 11 kilometers. Okay, so which means this is the variation, for the density. I'm not sure if it's density or pressure, but nonetheless both follow the same pattern. Okay, it varies. It basically is an exponential decrease. Okay, as height increases, density decreases. Okay, right, and hope that makes sense to all of you guys. So if no doubts, then let's go on to the next question. And please feel free to put your questions or comments in the chat box. Okay, so that helps us to improve. So they've given the ground reaction force as 15,000 Newton and the weight of the aircraft as 10,000 Newton. Find the vertical load factor. It's given that the vertical load factor is the ratio of the inertial force to the weight. Okay, so let's do this again. A pretty simple problem. So let's take an aircraft. Let's take a Sukhoi 30 Mark 1. Again, it's not a Sukhoi 30, but let's bear with me. So they have mentioned it's ground reaction force. Okay, so which means if the wordings are correct, then this has to indicate this normal force. Okay, if I draw the free body diagram, okay, free body diagram would be something like this. So there is this normal force, and there is this rolling force. Okay, so please be wary of these keywords in here. This is the rolling force, not the, because it's the rolling resistance offered. Okay, so this is the reaction force. So this normal force, so again, this is the lift, this is the weight, thrust, and the drag. So the normal force is simply the W minus L, okay, from our expression in here, if we do the analysis. So what's the vertical load factor in here at this point? So the vertical load factor has to be the ratio of the inertial force, which is this divided by the weight, okay, to the weight, because it's given in the definition. So that would simply be the weight minus L by weight. And since it's given ground reaction force, so given that your N is 15,000, so substituting that over here, so I can write N is equal to 15,000 by 10,000, which is equal to 1.5. Okay, so hope that makes sense to you all. Okay, so this is a pretty simple problem. Again, if they have given this as a rolling force, I mean, just once we get the actual question paper around Feb 21, we'll just confirm with it. Okay, but the approach remains the same. Okay, right. So hope everyone understood this part. So let's go on to the next question. So given that the airplane is flying at a velocity of 250 meter per second, it's meant but not second square, and the exit velocity is 550 meter per second, area is 1, density is 1. What is the uninstalled thrust? So again, it's a pretty simple problem. So the thrust is basically what? It is the mass flow rate times the exit speed minus the ambient speed. So let me just write the speed of the ambient air or speed of the velocity, basically. It's in relative sense. So what is this mass flow rate? So this is basically what? The density times area times the velocity of aircraft times the CG minus the speed of the air. So substitute all the values in here. It's 1 times U is 250 times it's 550 minus 250. And this is 300 times 250, and that comes around close to 75 kilonewton. Okay, so this is basically the uninstalled thrust. So I hope the data is correct, and this is how you do this problem. Okay, right. So let's go to the next question. If you guys don't have any doubts in this. So this is the last question of this part. Find VP by VA if perigee altitude from the moon is 25 kilometer and apogee altitude from the moon is 135 kilometer. Given that the moon radius is 1737 kilometer. So let's consider this axis in here. So this is our moon. Let's consider, because it clearly mentions perigee and apogee, so this clearly has to be an elliptic orbit. He says perigee altitude from the moon, so which means this distance, okay, 25 kilometer, and apogee altitude is this distance, which is 135 kilometer. First, we need to determine the eccentricity. Eccentricity is basically the distance from the apogee minus distance perigee, and it's sum of them. So how would you determine this R? Let's say apogee. It is basically the radius plus the 135 km, 135 kilometer, and the perigee is 1737 plus 25. Okay. So if you simplify, substitute it over here, you will get an answer close to around 0.0302. I hope my substitutions are correct in here. So once you get this, so you can we know the expression again, what is the velocity for at perigee? It is simply the angular momentum of the planet, let's say a moon, by the distance of the perigee, and velocity at the apogee is basically angular momentum of the moon by the distance at the apogee. Okay, so since they asked the ratio, so let's divide them simply. So it's VP by VA. This H moon gets cancelled off, so you simply have RA by RP. And what is RA and RP have calculated over here? It would simply be what? If I go to the next slide, so VP by VA is simply 1 plus E by 1 minus E, and that comes around to 1.0624. Right. I hope this value is correct in here. Just check it around. If the given data is correct, okay. This is a clear substitution, right? So I think with this we cover the flight and space mechanics, which, like I said, there are around 15 questions asked, so which was within the range that we discussed in the mock test series. Okay, fine. So once, there might be issues, but once we get the actual question paper on by Feb 21, we'll again create a new session in which we'll discuss each and every question in greater detail, right? So this is just a tip of an iceberg, okay, for you guys. Okay, guys. So if no doubts, then let's hand it over to Mr. Dinesh. I think he will be taking now the structural questions asked in the vibration part. Over to you, sir.
Yeah, so thanks, Praveen. I think you have done
Yes,
all
I
the
am done.
questions,
Yes. Yes, sir. Yeah.
space dynamics and all, right? Okay, no
Yes, sir.
problem. So
Okay.
let me start now. Take me presentation and let's start with the structures part. I think almost we got all questions. Okay, from structures, many question we got. So uh, yes, guys, there are three questions from space dynamics. Currently, we are not having datas. Okay, so once that response it comes by 14-15, we'll cover everything. Clear, guys? Because IGC will provide everything within 12 to 24 hours. Either it is answer key or the complete solution, because we are a team. You guys understand, right? IGC is not one person or two person institute. Okay, so we are a team and we will do everything. Yeah, yes, I understand uh, Ara and others. Okay, so I'll start quickly on structures. Okay, so guys, structures module have three subjects. Okay, three subjects in structures module. Okay, and we will see the questions related to these subjects. Okay, clear? So guys, let's start with first question. You guys can see my screen, right? So there are the, three subjects in structures module. We have strength of material, and in fact all the questions which are asked in this structures module are from our formula sheet itself. If you just follow IGC's formula sheet, you can solve almost every question for this structures module. So strength of material, second is aircraft structures, or we call flight vehicle structures or thin wall structures part, and then mechanical vibration. So we will see some of the questions, memory based questions. uh, yeah, it's a family, Guna. We we treat everybody as a family, usual. Okay, so first see first question and tell me after seeing this question, do we need to solve this question? Guys, quickly. Abhishek, Abhishek, do we need to solve this question? Those who are watching this session, please guys, quickly respond. Do we need to solve this question to find what the percentage change in volume? Anybody, do we need to solve this question? No, I know the answer, Mr. Desi boy. You can become Pardesi also. Okay, if you are from Hindi heartland. So I'm asking, not answer. I'm asking, do we need to solve this question? We need not to solve this question. Why? This is not gamma. The Poisson's ratio nu. The Poisson's ratio, guys, nu is given as 0.5. So when nu is 0.5, guys, tell me what is the K? What is the K? Shrey, when nu is 0.5, K will be infinity. So this problem is what? The given material is what? The given material is what? Perfectly incompressible, right? So you all know, right? Similar question we solve in IGC, right? So for perfectly incompressible material, what is the percentage change in volume? It's always zero, right? Because it's incompressible, right? then why we need to solve this question? Either this given data is correct or not, we can simply say we know what is the K, guys. K equal to what? Bulk modulus, right? It is what? E upon 3 into 1 minus 2 nu, right? Where nu is 0.5, your K is what? Infinity. And when K is infinity, there is no change in volume. So after just seeing the value of nu, you can answer this question within 1 second if you have solved IGC question, right? Because in IGC, one of the question they have told, for a perfectly incompressible solid, what is the value of nu? Right? Anybody remember this question? If you guys don't remember, go and check IGC notes. That question is there, okay? Or in a, okay, so let's see the next question, guys. Yeah, so this is again one question. Without solving, we can answer. In this question, what is given, guys? They given those two orientation. They given two orientation. So you can say case 1, case 2. In both the orientation, the value of stress is same. In both orientations are given at 45 degree. Is there any shear at 45 degree? Any shear stress at 45 degree? We have everything, Mr. Rohan Kumar. Online crash course also, in-depth online classes also, recorded classes also, everything. IGC Tech interactive classes, Mr. Rohan. You can contact us when you get free. Currently, let's look into session. So now in this case, you can say shear at 45 degree is 0. So what is this case? What is this case, guys? It's a case of pure shear. In case of pure shear, we all know, guys, what? The principal stresses are at what? 45 degree, right? And what is the values of principal stresses? It will be plus sigma and minus sigma. Clear? Right? Now you already, they asked at 0 degree orientation, what is the summation of stresses? So it is 0, right? This is sigma y, it is 0. This is sigma x, this is also 0 if you take at 0 degree. And we know these are principal stresses itself. Because when you take 0 degree orientation, it is a case of pure shear. Okay, so summation of principal stresses, which is what? Sigma 1 plus sigma 2, they asked, it is what? It is nothing but what? Sigma x plus sigma y, it was 10 and minus 10, so it is 0. Clear? So you guys know, right? We solved 3 question at least, similar question. I think there is a question in gate mechanical also. There is a question in gate XE also. If shear is not given, that means it is 0. Clear? Everybody, is it clear? 0 is the answer. Yes or no? Let's move to next question. What it says. Yeah. So again, this is the question which is again from formula sheet. They have given pictorial representation of what? Theory of failures, right? And they asked, what is question number 10? Answer is 18. Yeah, Vishwa, I think due to that data, right? In aptitude, you are telling, right? Question number 10 for aptitude. Yeah, all fine. No worry, Vishwa. Once let's response it comes, we will do all, postmortems. Vishwa, let's not dig into that. Our idea is to provide what should be the procedure. Okay? To solve, because these all are memory based questions. Okay. So theory of failure, pictorial representation. So guys, you know, this is what elliptical representation, and we know guys, elliptical representation is for what? Which theory? Elliptical representation is for which theory, guys? Anybody who can answer watching this session? So elliptical representation is done for what? Von Mises theory. Okay. Now guys, you can see inside this ellipse, this dotted part. So this dotted part is what? The graphical or pictorial representation of which theory? Hey Monty, don't tell to everyone like that. Whoever in IGC, if they message or you don't say anything like that. Okay, if you want, you can contact to IGC number. Okay, for any support. If you want to do self-study, just follow, keep quietly IGC work. Lot much of work is available on YouTube by IGC. You were telling something like work is not available. You see, IGC have two channels and we have done so much for people. In fact, every top ranker in India have used this year, who is going to be the top ranker or any ranker, IGC work directly or indirectly. You guys agree or not? IGC have provided almost all 16, 17 years of PYQ solution on YouTube. IGC have shared so many lectures on all basic subjects on YouTube. IGC have shared all the math lectures, aptitude lectures, and so many things. So the inner part is what? Tresca's theory, right? So did they have given other pictorial representation, guys, like maximum principal stress theory, this, right? Or you guys know, right, another theory, principal strain theory, which we can draw like this. Okay, so I think this was easy question, right? If you know theory of failures, pictorial representation, easily you can answer, and all these are already available with you all in IGC resources. Let's see next question, guys. Yeah. So in this question, I don't have data, but I will tell how to solve. Okay. So they given epsilon xx value, epsilon yy value, and they given tau xy is equal to a, or gamma xy. Was it gamma xy? I think it should be gamma xy. Quickly, guys. It should be gamma xy. They told the material follows the compatibility, right? And they asked the value of A. So we all know, guys, for 2D stress system, what is our compatibility equation? What is our compatibility equation, guys? For 2D stress system, what is our compatibility equation? It is given by what? Dou square by dou x dou y gamma xy, and this is equal to what? Dou square by dou x square, it will be epsilon y, plus dou square by dou y square, and it is epsilon x. So using this equation, we can find the value of unknown A. Clear? So this is what the simple question. You guys will be knowing, right? In prior year also, they have asked similar question, but it was for equilibrium equation. That time also they have asked some unknown value of A, but they given that time what? That time they gave sigma xx, sigma yy, and tau xy. And in fact, that was an NPTEL question, and same question was asked in GATE Aerospace. Okay, so in case of equilibrium equation, what it will be, they told in terms of absence of the body forces. So what is our equilibrium equation was? Sigma xx comma x plus tau xy comma y equal to 0. Using this, in that case, we found the value of unknown A. Clear? Can we move, guys? Next question. Okay. Yes. So again here, guys, I had two options available and two options I have added. This I have added. So read the question. What says? Each of the following is or are correct. Okay, this is one MSQ question from strength of material or aircraft structures basics. What it says: isotropic material has infinite plane of symmetry. This is correct, right? Because for isotropic material, the properties are same in all direction. In all direction, material properties are same, right? So A will be correct. Isotropic material will have what? Infinite plane of symmetry. Now what option B says? Homogeneous material properties are independent of location in or on material, right? That is also true. What is homogeneous material? Throughout material, the material properties are same. So your material property doesn't depends on what? Space coordinate, right? So that is what the meaning of this. Correct? Now I have added option C. What it says: anisotropic material has 21 material constant. Yes or no? You can say 21 independent material constant. Yes or no, guys? Correct? Quickly, guys, respond. So C is also correct. If this would have been the option, if this is not an option, then we will see when response sheet is out. Now the next, what it is? Question D. Option D. What it says? Isotropic material has 3 independent material constant. Is it true? For isotropic material, how many independent material constant, guys? Shania, how many independent material constant? That we don't have that option. You can type na, Mr. Desi boy. What was that third option which was correct? Okay, so guys, for isotropic material, how many independent material constant? We all know, right? How many independent material constant for isotropic material? Only 2, because this is also previous PYQ. So D is wrong. So this is how we can solve this MSQ. So let's move to next question. Yeah. Now, guys, there was one question from vibration giving pictorial views. Okay. And they asked which figure correspond to overdammed, critically dammed, and underdammed. Okay. I think Monty, we have answered your query already. Whenever you have put message here, all are preparing gate. They have already prepared for gate. Nobody will contact just like that in person. Okay. So please stop again writing. Okay. We didn't say you are a scammer, but nobody knows you personally, right? Then how they will contact you? Either you be in some group, join some institute, or don't join some institute, be in some open group like Telegram and all. Then you will get some friend, no? Okay, leave it. So this is another question. So we all know, guys, for underdamped, what kind of motion is? It is oscillatory motion, right? In case of underdamped vibration, the motion is oscillatory. So we can see the option A. It's a oscillatory motion. Now, guys, they told for no underdamped. I'm talking, not overdamped. First, now, guys, they told critically damped. So in case of critically damped, guys, we know it is a critically damped system will takes how much time? It will take minimum time to come to rest. Minimum time to come to rest. Okay. So which among C and B you can see taking the less time to come to rest. So you can say critical damp system is what? The minimum damping for which system is non-oscillatory, or it is the damping corresponding to that system will take minimum time to come to rest. Okay, so B is corresponding to critically damped. Now overdamped means the system will be more sluggish. The system will take more time to come to rest. So you can see the C kind of figure was for overdamped. Shreya, can you confirm the question was something like this? Shania, others? Yes or no quickly? Okay, thank you. So let's move to next question. What it says? Yeah. So you guys can see this is very simple question, trust question. Okay. So guys, in this question, what they have given a truss structure. Okay. There are two members, A to C and B to C. They are connected. Okay, usual, no problem. When we can let us see in detail. So this question, guys, can you check? Is it correct? Quickly, guys, respond to this. Is this question correct? Okay. So in this question, what you see, this is 2 meter. This is 2 meter. So if this is 2 meter, this angle will be 45 degree. So this will be 45 degree. Okay. And this will be what? 60 degree. Now what they asked in this question, okay, instead of 2 meter, it is 0.5 meter. Both. Is it so, guys? Okay, I understand. That's fine. I'm just telling ki what is the graph belongs to what. Because currently, without knowing paper, we are not God, right? Like others. Some people are sharing, guys, what? How many NATs, 1 mark, 2 mark, how many MSQs, 1 mark, 2 mark, every subject. Is it that possible? Vijay, is that possible? Others, you are sharing everything. Just like that, you have paper, actual paper. How you can exactly tell these many NAT, 1 mark, 2 mark, okay, without having paper in hand? Okay, fine, leave it. That part. Now come to this question. What? 0.25 meter, right? Okay, 0.5 meter, fine. Now guys, we know this is 45 degree, okay, and this is 45 degree, and they ask what? The force in BC, right? They ask force in BC, yes or no? Right? So how we can find force in BC? Just take at point C, sigma F in horizontal direction. Take the force equilibrium in horizontal direction. Okay, take okay, I got your point. Okay, Anyway, in that case also we can solve. Okay, we extended and then force is applied. Let me do in that next page. I'm just telling the crux how to solve this question. Okay, so I think this is, guys, you have this landing gear. So this landing gear can be idealized like this. Okay, this landing gear can be idealized like this, and they applied here force, okay, at some 30 degree. So first what we do, first find force in this member. This is C, A and B. Just resolve this force, given force in this vertical direction. So what will be the component? It will be F cos 30. Now once you know this F cos 30, how it will be? It will be acting like this. Now again here you can take the force equilibrium sigma FCH, okay, because we know this angle, guys, how much? 45 degree. Now one more question is that, guys, tell me, really will there be any force in BC? Really will there be any force in BC? Quickly, guys, will there be any force in BC if this? I think it's better. If you see in this case, there will be no force in BC. If I use this case, there will be no force in BC. Why? Because when you resolve horizontally, okay, there is only one force which will give me horizontal components, which is in BC. So from horizontal equilibrium, your sigma BC will be 0, because this is in vertical direction. Okay, so once we guys have the the proper question, we can talk more. Now next question, what it is? Yeah, so this is one of the questions from thin wall structure. Okay, and in these questions, what they ask, maximum normal bending stress. Now guys, in this question, no, why Pythagoras and all? See, we will solve this question, previous question, like truss question. Okay. Because guys, in landing gear, the landing gear can be idealized as a truss structure, and we can solve that. When you will have force in BC, if there is some reaction, okay, the vertical or horizontal reactions and all, so it's better like when we have a clear question, we can discuss more on that. Now guys, look into this question next, this maximum bending stress question. So guys, it's a C section. Is it clear? For this C section, I currently don't have data like H value, T value and all. I'll just tell how to solve this question. So guys, in this case, C section is what? It's a symmetric section. C section is what? Symmetric section. So IXY is 0. Okay, so when IXY is 0, your bending stress sigma Z will be what? It will be my upon Iy into x plus mx upon ix into y. Now in this problem, your my is also 0. So your sigma Z will be what? I think you guys can do calculation and all later. So I'll just tell how to find sigma Z. It will be mx upon ix into y. Now guys, where it will be maximum? Of course, it will be maximum at furthest aft point. Okay, so it can be either bottom or top. They have already given mx. We know y will be h by 2. You need to find ix. Okay, and then we can, what is the t value given? H is 1 meter. What is T value? Thickness? What is the T value? Okay, Shrey, I think that we can see later. No problem in that. So, what is the C value? T value here? So, once T is known, we can solve this problem. Okay, so T should be known, and guys, okay, it is 0.001. Now, what is the major thing here? You have to find Ix. So for thin walled structure, you should know how to find Ix. Okay, so if you take, it will be what? THQ by 12. Okay, this is Ix, and then it will be what? TH into plus minus H by 2 square. Am I correct? So this is how you can find Ixx using thin walled approximation. Is it correct, guys? Quickly, those who are watching this session, if find this session useful, can thumbs up? Yes or no? Not just BDQ by 12. It's THQ by 12 plus TH plus minus H by 2. It is not TH. The area, and you have to multiply by 2. Guys, it is one side and this is another side. So it will be 2 into, actually this is what? 2 into H by 2. So that's why it is TH into plus minus H by 2 whole square. Okay. So hopefully this was not a tough question and could have been solved by many people. Those knows basics well, and the calculation will be also easier. Now, guys, this is one of the questions from mechanical vibration, 2 degrees of freedom. So they given the equations of motion, guys. What they ask? The highest natural frequency. So if you guys see the equation of motion for 2 degrees of freedom, it is given by what? Those were given by what? M1 x1 double dot plus k1 plus k2 into x1 minus k2 x2 equal to 0, and then m2 x2 double dot plus k3 plus k2 into x2 minus k2 x2 equal to 0. Now if you compare, guys, we can find m1 m2, we can also find this k1 plus k2 and all these values. Once you know all these value, guys, then what will be your natural frequency? The natural frequency can be given by what? We all know, right? Natural frequency formula, guys. It is what? The natural frequency formulas, guys, we know m1 m2 omega power 4 minus m1 into k1 plus k2, I think m1 into k3 plus k2, then plus m2 into k1 plus k2, then omega square, then it is k1 k2 plus k2 k3 plus k3 k1 equal to 0. So using this we can find natural frequency. Okay, first natural frequency, then second natural frequency. They talked about highest natural frequency. Okay, yeah, 1.41 is the correct answer. Many people got in this case. Okay, 1.41. Now, guys, in this problem, one thing you need to know all these value. Okay, by comparing these equations. Okay, what is your k1 plus k2? What is k2? What is k1 and all? Okay, so I think I have written correctly. If I remember, yeah, k2, yes. Okay, so with comparison we can find the value of k1 k2 k3 by comparing and then using this natural frequency for 2 dimension for 2 degree of freedom, we can find alpha. Now one point is there here, guys. Are these values correct? Are these equation of motion correct? Yes or no, guys? If you tell me, then we can proceed solution. Are these equation of motion given is correct? I think I didn't get the correct data, but I'm telling the procedure how to solve this. And we have done similar question, guys, when we did not exactly same. We solved PYQs for all mechanical years. So there, I think 2 questions were there for finding natural frequency related to 2 degrees of freedom using frequency equation. Yes, Ujjwal, what you are saying? The answer is 1.73 you are telling? No, I think in group people were discussing under root 2 is the answer. So once I see the exact paper, I can tell. Question is correct, right? No, but this equation first, is this correct? And this equation is correct, corresponding to mass m1 and m2. Okay, if this is correct, so let's see what is your m2, m1. In this case, m1 is m. What is your m2? It is m. Now, guys, if you compare, what is your minus k2? Your minus k2 is equal to minus k. So you can say k2 is k. And then what we know further? K1 plus K2. So what is K1 plus K2? K1 plus K2 is 2K, right? Yeah, see, this is again problem. So I'm just telling you based on this given data, how we can solve. So you can see, you can compare this with this equation and you can compare this with this. Okay. So from here, I will find your K1 also K. Okay. And now, guys, if you compare this with this, again, I think it's not matching now. It cannot be like this. It cannot be like this, Mr. Desi Boy, because from here, if you see, your K2 will be coming minus 2K, which is not possible. Okay. So I'm just sharing how to solve this question, and this was a not that tough. It was again a approachable, easy question from mechanical vibration. So that's all from my side in structures module. So I can say more of all the questions are easy. We have to check that trust based question if anything is there in that question. Otherwise, you all can solve all these question. Okay, if you have learned well. So that's all from today's session from IGC, guys. So guys, those who are looking a right support with a dedicated team, we have a mentors. They are topper of their own time. Many of them are working in industry, so you get both academic as well as industrial experience when you learn with IGC. IGC have strongest alumni network also across all the institutes in India. So when it comes to post-grad guidance, nobody can come near to IGC. IGC have got many people in recent last 2-3 years in PSUs like in DRDO, in HL. In coming days, you will see many IGCians in BGC also. We also provide complete support for ICRB exam, for ISRO exam. We have provided brief support for Airport Authority of India exam also, and in future we'll be also supporting for exams like FCAT and all. So that's all, and I'm pretty happy. IGCians have done very well. They are very much satisfied there with their paper. the performance put by them, because we have pushed them very hard in last 2 months, especially making sure everybody write mock exams with as sincerity. IGC's mock exams are always very tough exams. Okay, so thank you all for watching this session for so long. And if you guys have any doubt now, you can put. I think some people were asking some questions. I have attempted 50 question. Will that not good? So I think, guys, 50 question means you may get a 2-digit rank if your accuracy is good. Okay, Shrey, the cutoff can be 28 to 30 marks around. Okay, it will be little high this time, because I can see in structures questions itself, those who have learnt well, they will be surely doing well. Also those who have prepared well using PYQs, they may also do relatively well. And this year IGC have given so much of free work, right, Abhishek? Many people used IGC's thin-walled, lectures or other lectures. So the people may do well relatively this year compared to other year. Okay, so the average marks will be high. So the gate score may be, compared to previous years lesser. Shrey, this paper is going to be tricky. Okay, not in terms of like with the very few marks, even with 2 marks around, the rank may suffer like 50 to 100. Especially there will be two competitive ranks, or you can say between 40 to 150 or 200. Okay, with very less margin, because I have seen the 2018 result. Okay, so I have enough experience. When paper comes easy, how fast rank suffers with very small marks. Okay, any other question, guys? I think there was one more question initially somebody was asking. I don't know what was the question. I think the attempt 50. I guys, 50 is not a bad attempt, but if you want to secure 1 digit or very good 2-digit rank, then 50 is not an enough attempt. Okay. So Desi boy, how was your attempt? How much questions did you attempt? Okay, I think we have done. So let's sign off. Thank you all for watching this session. And guys, we will come back with a complete detailed solution once response it comes out. And those solution will be done on IGC's Gate Aerospace channel. Okay, so we will be solving solution part, detailed solution part on IGC's other channel, Gate Aerospace IGC. Okay, so catch you all once response it comes out. Thank you all. Okay, guys. So again, on this happy note, let's sign out. And IGC is starting a live interactive batch for Gate Aerospace from Feb 18th. So interested people can join that batch happily and enjoy happy learning. Thank you all. Bye. Good night.